So now we will do Newton's third law of motion. See here, in this case, first we write here Newton's third law of motion. See its statement first. To every action, there is equal and opposite reaction. So this is the statement of the Newton's third law of motion. So now let us understand what is action and what is reaction. First I will take simple example. You know, when you walk on the road or on the ground, how do you walk? You push the ground downward with your feet. As a result, ground applies force on you. That is called reaction. So you are pushing the ground downward, that is known as action, and ground applies force on you, that is known as reaction. But see here, this action and reaction pair, action and reaction both act on two different bodies. So as I have told, as you apply force on the ground, that is action. So it means you are applying force on the ground and ground is applying force on you, that is known as reaction. So see, action is acting on the ground, reaction is acting on you. So this is an example of Newton's third law of motion, and we can explain walking only using Newton's third law of motion. Now we will take another example of this where we can explain action and reaction. See here, in another example, we can take, suppose there are two spring balances. Here you have connected one spring balance. See here, this is a spring balance A, this is a spring balance B, and here we can take a scale. When you pull this spring balance this side, this you are applying force on spring balance A. Now you will see here, the reading shown by spring balance B will be same. So when you pull spring balance A, B is also pulled. As a result, B pulls A to this side. Both are applying force on each other. So force applied on A is known as action, and force applied by B, that is known as reaction. So because these action and reaction are equal, so both will show equal and opposite readings. Now another example, we can take recoil of gun. You must be knowing about when bullet is fired, that is gun is fired, what happens? When bullet is fired, bullet moves forward with the greater speed. As bullet moves forward, so it means gun applies force on the bullet. Now what happens in next case? Bullet applies force on the gun, that is equal and opposite force. Because of that, gun moves backward. So while firing, you have to hold gun very tightly, very forcefully. So as gun moves backward, this is known as recoil of gun. So this is also an example of Newton's third law of motion. Another example of rocket. You might have seen in rocket, what happened in rocket? You might have seen the shape of the rocket is like this, and fuel is here. When it burns, gases burns or fuels of the rocket burns, the flames comes out. these flames comes out with the great speed and they apply reaction to this side. So, as these gases comes out with the great speed, so they apply reaction on this rocket. Because of this rocket goes up. So, here it is also working on action and reaction. Whatever is the place, whether it is in space, everywhere rocket can move because it is working on the action and reaction. Action and reaction is coming due to burning of the gases. It does not require ground or any atmosphere. Now, see another example of the horse. You know, horse, if you have taken horse cart, it also actually horse cart moves due to action reaction. Horse pushes the ground downward. As a result, down applies the force on the horse. Because of this reaction, horse is able to pull the cart in the forward direction. But see, a horse cart you cannot move in space because there is no reaction. It cannot get any reaction over there. So, these are the example of action and reaction related to Newton's third law of motion. But very important about Newton's third law of motion is there action and reaction both acts on the two different bodies. They are not acting on the same bodies, and both the bodies may have different acceleration because both the bodies may have different masses. So, not necessary they will have the same acceleration. So, here in action and reaction it is very important, as I have told you, recoil of gun while walking, movement of the rocket, pulling of the horse cart. All these examples are very important here, and you have to do with proper way. While writing, you have to take care each and every step should be completed in proper way. Now, we will discuss linear principle of linear momentum, that is conservation of linear momentum.